So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the fifth largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, Studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet. Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, It doesn't look like a round object, it's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star while the other side remains in perpetual darkness. So one side is always very hot while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them, there might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and two planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its two giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation.
The Sun is getting ready to flip as its magnetic poles are reversing. Similar to Earth, the Sun has a magnetic north and a magnetic south. But unlike Earth, the reversing process of the Sun's poles is more frequent and easier to predict. The next flipping is expected to take place this year between April and August. As apocalyptic as it might sound, you don't have to worry. If you're around 30, you've already experienced this phenomenon more than once as the Sun flips every 11 years. You probably didn't notice any changes back then because this process doesn't impact Earth's life so much. But this time, things might be a little different. On Earth, ocean currents are movements that play a crucial role in influencing both climate and weather by distributing heat from the equator to the poles. On the Sun, these currents are more like an ocean of plasma, but they not only transport heat, but also carry electromagnetic energy. That happens because the Sun is a huge ball of hot and ionized gases that keep flowing inside its core. By fusing together hydrogen atoms and forming helium, our star releases a massive amount of energy, leading to these very heavy flowing electric currents. And whenever you have currents, you have magnetic fields. It's easier to understand if you think of that classic experiment with a wire and a nail that you probably conducted in elementary school. When electricity flows through a wire, it creates a magnetic field around the wire. So when you connect a wire to a battery and wrap it around a nail, the nail becomes a magnet. This is similar to how electric currents create magnetic fields on the sun. This whole process, with the help of which the sun generates its magnetic field, is called a dynamo. We can't observe it directly, but we can see its effects on the sun's surface. When plasma and magnetism flows become unstable and intense, they manifest as sunspots. You know, those dark areas on the sun's surface? Much about how the dynamo works remains a mystery. But scientists have learned something important after observing these sunspots for centuries. The dynamo process follows a pattern. About every decade, it reorganizes itself. The sun's polar magnetic fields get weakened, eventually reaching zero, and then they return, but with the opposite polarity. Back in the 50s, researchers figured out that when sunspots start to ramp up and become more intense, it means the poles are gearing up for a reversal. And over the past few years, solar activity has been off the charts. We're talking about more solar flares, more electromagnetic radiation bursts, and more plasma blobs being ejected into space. It's like we're sitting in the front row at the solar system's most epic fireworks display. In fact, the sun hasn't been this lively in probably 2 decades. Right now, experts think the polar fields are almost in sync and steadily weakening, inching closer and closer to zero. But we haven't reached the point of reversal yet. Although it might sound like the sun flips its magnetic poles like clockwork every 11 years, the truth is that it's not as neat as it seems. This path can be bumpy, and some aspects of the phenomenon are still very hard to predict. Take the last solar cycle, for example. The Northern Hemisphere started its magnetic flip back in early June 2012, but then it kinda hit a snag and lingered around the neutral point until late 2014. Meanwhile, in the Southern Hemisphere, things were smoother, with the polarity switching over in mid-2013. This time around, the sun is actually playing nice. Things seem to be running way smoother this cycle, with the poles transitioning more evenly. But here's the thing, reversal processes are never the same. That's what makes this phenomenon so interesting to observe. But at the same time, it's hard to predict how it'll affect us down here. Here on Earth, we don't have to worry too much about those intense sun explosions happening 93 million miles away. But if, and I emphasize if, a solar storm were to reach our planet, the main threat it would bring would probably be the disruption of communication satellites in space. However, things might be different in this cycle reversal happening in 2024 because the number of satellites has skyrocketed in recent years. For example, Elon Musk's Starlink system alone involves more than 4,000 of them. All these satellites, along with communication and GPS satellites, could be impacted or even destroyed by a powerful solar storm. Although the chances of a powerful solar storm hitting Earth are low, it's not impossible. Back in 1859, during the Carrington event, a storm occurred near the peak of the solar cycle, causing currents to surge through telegraph lines, sparking fires and disrupting messages worldwide. Earth fell silent as telegraph communications failed. Just imagine what a solar storm could do to our vast number of satellites today. It could affect everything we rely on daily, from space-based communication and navigation to weather forecasting services. The ground-level power distribution could also be affected. You can forget about watching YouTube or Brightside, because if such an event occurred today, it would cause an internet apocalypse, sending countless people and businesses offline. There's a prediction that says that if a Carrington-class event happened today, it would result in damages ranging from $0.6 to $2.6 trillion. And I'm talking about the United States alone. Fortunately for us, solar storms as intense as the Carrington event happen only once every 500 years or so. Bad news for communication satellites, but great news for aurora watchers. During the Carrington event, dazzling auroras borealis lit up the sky as polar light shows stretched far beyond their usual ranges. The northern lights were spotted as far south as Cuba and Honolulu, Hawaii, while the southern lights were seen as far north as Santiago, Chile. For many people around the world, this was their first glimpse of the aurora, leaving them obsessed with the unusually bright skies. Some of them thought it was the end of the world, while others began their day early, thinking the sun had risen after hearing birds chirping and seeing the bright skies. Today, we know there's nothing strange about it, considering that the appearance of auroras at lower altitudes is one of the expected effects of the sun's magnetic pole reversal. Typically, these dazzling phenomena are found between 60 and 75 degrees latitude, but during the last magnetic pole reversal in 2013, intense auroras were observed below 50 degrees. Eyewitnesses describe these auroras as blood or deep crimson red, shining so brightly that you could read a newspaper in their light. It's important to study this phenomenon and not to fear it. The inversion of the magnetic poles on the sun is actually a great opportunity for scientists to better understand how our star works. Since many pieces are still missing in the whole dynamo situation, we're still not very good at predicting why some solar cycles are more intense than others, or when exactly a coronal mass ejection will erupt. But being able to predict that is becoming more and more necessary as we venture ourselves into space. The more people are out there beyond Earth, the more exposed they are to these strong solar storms. That's why the scientific community wants to know more precisely when a solar storm can cause damage to spacecraft and space stations. Plus, it would help meteorologists make progress in predicting weather, not only on Earth, but also in space. The whole point is to make space travel safer as the interest in crewed missions to the Moon and Mars grows every year. Another reason why it's important to learn more about the Sun's pole inversion is to better understand how the mysterious interior of the Sun works. That could actually help us figure out the aspects of other stars in the universe and maybe get closer to answering the ultimate question: why are we here?
See this? You're looking at the best full portrait of the Sun by far. Thankfully, our 4.5 billion-year-old parent star didn't use any makeup to fix its skin tone before this photo shoot. And now we can study its surface in great detail. This iconic image was taken in March 2022. NASA wanted to gain a better understanding of solar behavior and its impact on life on Earth, and the future of our space technologies, of course. To do so, they launched the Solar Dynamics Observatory Satellite, or SDO, mission in February 2010. This legendary photo shoot happened 12 years later, when SDO was halfway between the Earth and the Sun. Scientists had to assemble 25 individual images like a puzzle, so the final image contains 83 million pixels. Yeah, the resolution is about 10 times better than your fancy 4K TV screen. Look at this amazing cookie-like pattern. Typically, the bright surface of the Sun overshadows it when we observe the star from Earth. Thankfully, NASA explored the light beyond the visible range, which allowed them to discover some invisible details of the Sun's face. When you adjust your selfie with filters and effects, you can end up with completely different portraits, highlighting different spots of your face, even those you didn't know existed. The same principle works here. All these plasma balls are the same photo of the Sun, captured at different electromagnetic wavelengths. The revealed spots and patterns can help us understand events happening inside the Sun's skin a little better. At the speed of light is supposed to mean super quick, but this rose gold ray caressing your cheek at dawn has come a long way and is incredibly old in human terms. Photons generated by the Sun's core take between 10,000 to 170,000 years to travel through the star's atmosphere, and then around 8 minutes more to reach Earth. So let's explore what's taking them so long. Our tour begins with the upper layer of the Sun's atmosphere. Remember solar deities in movies and theater plays? They often wear luxurious crowns with golden rays. Well, the real Sun does wear a fancy corona too, which is the outer layer of its atmosphere. But of course, its size and glory are incomparable with those plastic costume crowns. And its shape is not so stable. Corona is a gas shell enveloping our parent star, so its size and form constantly fluctuate under the influence of the Sun's magnetic field. You can spot this crown with the naked eye from Earth during total solar eclipses. It looks like a beautiful, intense radiation around the solar disk, which itself is completely blocked by the Moon. The corona stretches 5 million miles above the Sun's surface whereas our blue planet is only about 8,000 miles in diameter. So, one hypothetical ray of the corona equals a row of about 625,000 Earth-sized planets. And suddenly, all my problems begin to seem tiny. Now here's another fun fact. The sun's corona kind of breaks the laws of known physics because it's hotter than it should be. Its temperature reaches 2 million degrees Fahrenheit, whereas the surface of the sun is only about 9,000 degrees. Although the word "only" doesn't fit here, because it's still super warm in human terms. Usually temperature tends to fall as you move farther from a heat source, but it's not the case here. Space scientists are still scratching their heads trying to investigate this mystery. Thankfully, the recent photo shoot allows us to explore what's going on inside this massive hot stuff without risking losing our sight. Take these beautiful bright spots, for example. They depict solar flares happening under the corona layer. Solar flares are powerful explosions that happen when magnetic fields bump into each other. When it happens, they change shape and quickly reorganize. These fields arise from plasma, which is very turbulent itself, so these events are no surprise for the local weather. Now, who would have thought that the sun has dark spots on its skin, just like people? These darker areas are known as coronal holes. Earthlings can experience their impact when they observe the beautiful aurora lights in the polar regions. Coronal holes look darker because plasma in these spots is cooler, less dense, and magnetically open. These conditions allow the solar winds to escape outward across the solar system rather than hang out at the sun's surface. And when they bump into the Earth's magnetosphere, auroras emerge to fascinate our eyes. Thankfully, the local fields cool down the solar winds. Nobody wants their eyes to melt, right? Now, if we were looking for an analogy to the sun's hairs, the best candidate would be solar prominences. These large, bright plasma loops arise from the sun's surface and stretch for thousands of miles into space. Their lifespan varies from days to several months. It's one of the most common events in this region. Although the first detailed description of solar prominence dates to the 14th century, modern scientists are still researching how and why they're formed. Diving further inwards, we're facing the transition region. The thickness of this layer is about 62 miles, and the local weather is unthinkable. Temperatures can rise up to 900,000 degrees Fahrenheit. The transition layer sits between the corona and the last region of the sun's atmosphere called the chromosphere. Now, speaking of which, welcome to our next stop. The chromosphere region is famous for a scientific mystery called a spicule. Come on, say it with me. Spicule. Yeah, that's fun. These spectacular grassy-like jets of plasma fire upwards from the surface of the sun and reach speeds of approximately 224 miles per second, as if they're jumping on a trampoline from the surface of the sun. Each spicule lasts for just a few minutes in outer space before falling back into the solar atmosphere. Astronauts were having a challenging time trying to explain how magnetically charged particles could manage to escape the massive gravity of the sun while being so close to it. The possible answer emerged in 2017. A group of scientists discovered that neutral particles provided the magnetically charged particles with extra buoyancy to escape the solar gravity for a while, which is better than my cousin's explanation, which is happy thoughts and pixie dust. Yeah. Now let's go ahead and travel 1,000 miles inward toward the chromosphere to finally reach the solar surface, the photosphere. It's around 248 miles thick, but unlike planet Earth, the sun's surface is not solid or stable at all. The temperatures here are insanely hot for any matter to exist. On the other hand, scientists often call plasma the fourth state of matter. And why not? It's made of ionized atoms and free electrons, so it kind of deserves to matter. So what's the matter? Maybe someday we'll happen to meet the local civilization of plasmoid people, but I think it's best that we skip their welcoming warm hugs. You know, hot, hot, hot. Anyway, the photosphere is our final stop, because humankind doesn't have the technology to explore the sun any deeper. So if you want to learn more, you'll have to invent your own spacecraft. But time's a-wasting. You'll only have about 7 to 8 billion years. After that, our sun will fade away, according to scientists' estimates. Actually, those same scientists will be going first. Now, you have a serious competitor, though. NASA's Parker Solar Probe is the current champion for the deepest dive into the sun. This spacecraft managed to travel 4.5 million miles from the Sun's surface toward its core on September 27, 2023. And then the Parker probe repeated its own record once again in December of the same year. So, why didn't it melt, I hear you asking? The probe has been designed to withstand insanely intense conditions and temperature fluctuations. It's equipped with a custom heat shield and an autonomous system protecting the mission from the massive solar lights. NASA has further ambitious plans. In December 2024, Parker will make its closest approach to the Sun. It will travel faster than any man-made object has ever traveled, at the speed of 435,000 miles per hour. The probe will be just 3.8 million miles away from the Sun's glowing hot surface. It's like landing on a star. Astronomers have already compared this epic upcoming milestone with the moon landing. I'm thinking, however, it might be safer if we, landed at night. Yeah, you're right, that's an old joke. If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Yarkovsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX, and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. Osiris Apex will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. Osiris Apex has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare. It was 1994. It was dark, so no one saw two silhouettes opening the emergency exits of a glass dome complex in Arizona known as Biosphere 2. They were determined to free 7 people locked inside for a month, risking their lives in the name of science. The mission was accomplished, but they got hit with trespassing and vandalism charges. The vandals were Abigail Ayling and Mark Van Thillo. They were among the first 8 poor devils who lived in that place as guinea pigs, and they didn't want anyone else to go through the same horrors they had experienced. $150 million were spent to see if humans could create suitable living conditions on other planets, like Mars. To do this, scientists built a mini-world with over 3,000 species of plants and animals. Biosphere 2 was a sealed-off 3-acre habitat, complete with its own mini rainforest, a private beach with a coral reef, a grassland savanna, a marsh, and even a desert. Between 1991 and 1993, nothing could enter or exit that place. The group of 8 people locked inside called themselves Biospherians, rocking matching Star Trek-like jumpsuits, growing their own food, and breathing their own air. They began with high hopes and a 5-star hotel-style breakfast, but things took a darker turn over the months. The whole team was starving and turning orange. In Biosphere 1, which is the real Earth, you can order a pizza in 2 minutes. But inside Biosphere 2, it took them an endless 4 months to whip up a margarita-style pie. They had to harvest wheat for the dough and milk goats for the cheese. The goal was to be completely self-sufficient, and they became part of an atmosphere, quite literally. When they breathed out, their CO2 fed the sweet potatoes they were growing. And those sweet potatoes became part of them since they were essentially eating the same carbons over and over again. They had so many sweet potato feasts that their skin actually turned orange from all the excess beta-carotene. What seemed like a funny situation at the time highlighted a big issue. The crop yields in Biosphere 2 were a total disappointment, and the crew was starving. They were going crazy from hunger, and moments of sudden anger led to doing regrettable things, like stealing bananas from the basement storeroom. At some point, the freezer had to be locked. Over the first 6 months, each of them lost between 18 and 58 pounds of weight. Every day, someone took charge of weighing out fresh food for the cook, logging the information about nutrients into the computer to make sure the crew hit their recommended calorie, protein, and fat goals. Initially, meals were served buffet-style, but as the crew got hungrier, the cooks started to meticulously divide their food into equal portions. Their diet, mostly sweet potatoes, carrots, fruits, and occasional meat on Sundays, were supposed to keep them going during those exhausting 80-hour work weeks of heavy physical labor. Biospherians were leaving every meal still hungry, and they had recurring dreams of McDonald's hamburgers, sushi, Snickers bars, and cheesecake. The air was running out. The entire place was completely sealed, with steel and glass at the top and a solid steel floor underneath. Managers made sure to check everything coming in to avoid synthetic materials emitting harmful gases. Living areas were furnished with wood and wool, and they couldn't use chemical deodorants or blow out birthday candles. Biospherians were counting on the food they grew and their many rainforests to produce enough oxygen for them to survive. However, they were losing oxygen very fast, drowning in their own carbon dioxide emissions, and worst of all, they had no idea why. With another 9 months of the experiment to go, oxygen levels had dropped from 21% to around 15%, which feels like living at the top of Mount Fuji. They felt awful, basically dragging themselves around the biosphere. They couldn't even finish a sentence without stopping to catch a breath. Then sleep apnea kicked in, with some of them waking up gasping for air. To bring down the carbon levels inside Biosphere 2, they tried some desperate moves, like growing plants like crazy, cutting back on watering the soil as much as possible, and even giving up on tilling. Nothing worked. So everyone decided they had hit a dangerously low point and asked for help. Refrigerated trucks showed up to pump more pure oxygen into Biosphere 2. As soon as the gas started flowing in, they burst out laughing and began running around. The ecosystem was a total mess. Hummingbirds and honeybees vanished after a couple of months, so plants weren't getting pollinated anymore. Worms and broad mites attacked crops, and cockroaches just took over. 4 species of cockroaches were brought inside to recycle organic matter, but the regular household cockroach was the ultimate survivor. They somehow sneaked in and multiplied, becoming a serious threat to crops. At night, the kitchen got flooded with cockroaches as soon as the lights went out. To combat the infestation, the group greased coffee mugs with lubricant and put pieces of papaya inside as bait. Roaches would climb inside, but they couldn't scale the slippery sides to escape. Being hungry, lacking oxygen, dealing with bug infestations, that's enough to make anyone go nuts. Heated arguments led to cups being thrown and people being spat at. Eventually, the whole group just split into 2. They stopped talking and could walk right past one another in the hallways without even making eye contact. Half of them wanted more food and oxygen to continue the research with some dignity, while the other half believed in survival without external help, no matter the costs. The truth is, the sealed chamber had been breached long before that. Just 2 weeks after they got inside, a biospherian named Jane Pointer cut off the tip of her finger in a cooking accident while making rice. The mission's doctor tried sewing the tip back on, but it didn't work, and her finger turned black within days. She went to a hospital outside for surgery, and a couple hours later, she sneaked back inside, carrying a duffel bag filled with supplies like computer parts and color film. Reporters would only learn of that sneaky delivery months later, and because of that, many people have questioned the credibility of the entire experiment. Media treated the experiment like a reality show, branding it as trendy ecological entertainment. Headline news around the world made it sound as if they were on the brink of losing their lives, to the point where families were concerned, calling the biospherians to check if they were really okay. The group felt like they were in a human zoo, with tourists coming from far away to peer into the glass cage. In the first 6 months alone, more than 150,000 people visited the place. Biosphere 2 ended up becoming a pop culture punchline, inspiring a comedy movie called Biodome and decades of funny sketches. You might be wondering why none of them quit the experiment and walked out the front door. Well, none of the environmentalists wanted to be the first to admit it was too much to handle. Plus, they were all still hopeful they could somehow crack the puzzle of building Earth number 2. By the end, they had managed to find 7 tons of missing oxygen. It had been absorbed by the concrete. Even though being breathless all the time might seem like the biggest challenge they face, the biospherians said that learning how to deal with people in a closed environment was even harder. It looks like the experiment was a huge failure, but the group did learn a lot of valuable lessons. They proved that a sealed ecosystem could work for years. They contributed to studies on reef restoration, and their farms showed that high productivity and full nutrient recycling could be achieved without toxic chemicals. In case you wonder, this wasn't the end of the glass complex. The second mission inside Biosphere 2 took place in March 1994. Now, you can go back to the beginning of the video to understand how that worked out.
Saturn's iconic rings will disappear in less than 2 years. Soon, we won't be able to see Jupiter's Great Red Spot. Pluto's atmosphere might vanish any day now. Even the universe itself could be slowly evaporating right at this moment. But let me start from the very beginning. Saturn's rings won't vanish forever, at least in the near future, but they will seemingly disappear from view. This phenomenon is caused by the planet's tilt as it orbits the Sun. As a result, the eye-catching rings adorning the gas giant will get invisible to stargazers in 2025. This outrageous disappearance occurs because Saturn's thin rings turn edge-on. It's like holding a sheet of paper horizontally at eye level parallel to the ground so that only the edge of the paper can be seen. Something similar happens to the gas giant's rings. As the seasons on the planet progress, instead of the southern side of the rings tilted our way, we start seeing the northern side. But then the planet tilts again, revealing the southern side once again. Such a ring plane crossing happens every 15 years when our planet passes through the gas giant's ring plane. The last time this phenomenon occurred was in 2009. Afterward, the rings gradually became visible again over the course of several months. This time, the rings will be on edge in March 2025. Then they will slowly come back into view and disappear again in November of the same year. Soon after that, the rings will reappear, first becoming visible to the largest telescopes, later for everyone else to see. At the same time, further into the future, the rings might cease to exist for good. Astronomers have concluded that Saturn's rings, which mostly consist of ice and rocky dust from smashed asteroids, are younger than we thought. They're losing tons and tons of mass per second all the time, and it's likely to be a few 100 million years at most before they vanish completely. Let's move to the Great Red Spot on Jupiter. This immense raging storm might stop spinning in the next 20 years. The storm in question is larger than our planet. It was first spotted in 1830, but observations from the 1600s mentioned the presence of a giant spot on Jupiter too. If it was the same Great Red Spot, then we can say that the storm has been raging for centuries. The storm's vortex has remained so powerful thanks to Jupiter's 300 to 400 mile-per-hour jet streams. But like any other storm, the Great Red can't keep raging forever. It's been shrinking for a long time. In a decade or two, it's predicted to turn into GRC, the Great Red Circle, and who knows, maybe it will later turn into the GRM, the Great Red Memory. In the late 1800s, the storm was more than 35,000 miles across, 4 times the diameter of Earth. But when Voyager 2 flew past Jupiter in 1979, the storm had already shrunk almost twice its original size. And this shrinking is still happening. In 2017, the GRS spanned the width of a bit more than 10,150 miles, less than 1.3 times the diameter of Earth. Moving on, Pluto's atmosphere is going through a weird transformation. This icy dwarf planet sitting over 3 billion miles away from Earth in the region of the Kuiper Belt drew astronomers' attention in 2018 when it passed in front of a star. With such a powerful source of light illuminating Pluto, researchers managed to examine the dwarf planet and its atmosphere. They came to a shocking conclusion that Pluto's atmosphere is refreezing back onto its surface as the dwarf planet gets colder and colder. Astronomers used several telescopes in different spots in the USA and Mexico to observe Pluto and its thin atmosphere, which is mainly made of nitrogen. This atmosphere is supported by the vapor pressure of ice on the surface of the dwarf planet. For around 25 years, Pluto has been moving further away from the Sun, and its surface temperature has been gradually going down. Pluto is really far from our star at the moment, but at one point it will start getting closer in other regions of its incredibly huge orbit. Besides Jupiter's Great Red Spot, Saturn's rings, and Pluto's atmosphere, we're also losing stars. But stars don't vanish, right? For thousands of years, scientists believed that lights in the sky were fixed and unchanging. Even after they realized those lights were physical objects, just like the Sun, they were still sure that stars went through major changes extremely slowly, on timescales of millions and billions of years. In reality, though, the most massive stars, which can be hundreds of times heavier than the Sun, can go through sudden catastrophic events. For example, once they reach the ends of their lives, they pass away in blinding explosions of supernovae, shining for months on end and visible across hundreds of millions of light years. But there are stars that seem to just wink out of visibility. It should be impossible. And over the past years, a group of researchers tried to figure out whether there's actually a chance of such a phenomenon happening. They started to compare data collected over decades of observations. The project is called VASCO, the Vanishing and Appearing Sources During a Century of Observations. The scientists are interested in all kinds of disappearing objects, but they're hoping to find a star that was steady and present for a long time, and then just vanished without a trace. Even if you point a super powerful telescope there, you'll still see nothing. Our current understanding of space and its laws suggest that stars change very slowly over long periods of time. Dramatic disappearances are supposed to leave noticeable traces behind. Of course, it doesn't mean that all stars should shine steadily. The sky is filled with stars that change in brightness and pulsate. But VASCO is about something very different. They want to find something that goes from a completely steady star to vanishing entirely. Such a phenomenon hasn't been documented yet, and such a discovery might lead to new physics. And now, let's move on to the most disturbing part, the one about the evaporating universe. According to a famous theory proposed by Stephen Hawking, black holes, the densest objects in the universe, evaporate over time. They lose mass in the form of bizarre radiation. But a new study claims that Hawking radiation, or something very similar to it, might not be limited to black holes. It's likely to be everywhere, and it could mean that the universe is slowly but surely evaporating right in front of our eyes. Now, Hawking radiation is something no one has ever observed, but theories and experiments suggest that it can actually exist. Let's see how it works. There's a misconception that black holes are cosmic hoovers, slurping up everything that comes too close with the help of their immense gravitational pull. In reality, though, black holes don't have more gravity than any other body of a similar mass. What they're famous for is their density, incredible amounts of mass packed into a tiny, tiny space. Within a certain proximity to such a dense object, gravitational pull becomes so powerful that it becomes impossible to escape. Not even the speed of light in a vacuum is enough, and that's the fastest known thing in the universe. At the same time, anything massive or dense enough can produce a serious curvature of space-time. In simple words, the immense gravitational field of these objects makes space-time wrap around them. Even though black holes are the most extreme example, space-time also curves around other super-dense objects, like white dwarfs, and neutron stars or galaxy clusters. It means that any super-dense and supermassive object can have some sort of radiation similar to Hawking radiation. And after a very, very long period of time, it could lead to everything in the universe evaporating, following the fate of old supermassive black holes. If it turns out to be true, it will change our understanding not only of Hawking radiation, but also our view of the universe and its and our future.
In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was that this was a comet or asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of our solar system closer to the sun. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants of the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they have no ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet, because it seems to come from a different location in the universe. Yet, it doesn't exhibit the typical signs of cometary activity. Oumuamua lacks a tail and does not spew out gas as it passes by, not like me. Even though it behaves like a comet, it looks more like an asteroid. Now, another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time. And it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it's simply wanted to be seen. Now, another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Now, Neptune-like planets may play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper Belt, a reservoir of comets in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. Oumuamua was also linked to a peculiar theory about how life came to be in the universe – panspermia. Now that's a hypothesis that suggests that life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, or even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the theory that this comet in particular has transported life between star systems. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves so strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our sun, the faster it became, releasing that hydrogen and also changing its path to our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears his name. What's interesting about it is that it's, well, spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. After it was first noticed in August 2019, astronomers studied its path through our solar system and concluded it came from another star too. But Borisov gave us more time to study it because we spotted it earlier in its journey through our neighborhood. Researchers used advanced telescopes to look at the dust coming off Borisov. They found it's throwing off over 400 pounds of dust every second. They also found Borisov has more carbon monoxide than comets from our solar system usually do. But the amount isn't the same everywhere on the comet. This tells us the space object probably started forming near its home star before moving away, maybe because of larger planets in its system. The light from Borisov is way more polarized than light from other comets we've seen, and its cloud is super smooth. This tells us Borisov has never interacted with another star. The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international dateline, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere. There are probably 36 other civilizations hanging out in the Milky Way, and over 170 billion galaxies, give or take, in the observable universe. Conditions for life are all over space. So, where is everybody? Nuclear physicist Enrico Fermi came up with this exact same question during a lunch break with his colleagues in 1950, leading to one of the most unsettling paradoxes in the universe. Even though there's a huge probability of extraterrestrial civilizations existing, we still haven't found any clear evidence of them. One possible explanation comes from the zoo hypothesis. It suggests that advanced extraterrestrial societies exist and know exactly who we are and where we are, but intentionally choose to stay hidden. They're just observing human quirky behaviors, as if we're in some kind of a cosmic wildlife park. But their intentions could be much darker. If you're a Star Trek fan, you probably remember the main rule for Federation members. Starfleet officers shouldn't contact species that are not advanced to avoid messing with their development, even if it means risking their own lives. Now, even though it's fiction, this rule perfectly captures what the zoo hypothesis is all about. Beings from other corners of the universe see our planet as a cosmic zoo with one-way bars. They can watch us brushing our teeth in the morning or walking our dog, but we can't catch a glimpse of them. In this theory, non-terrestrial life forms deliberately keep their distance from us, sticking to a hands-off policy agreement in the vast cosmic neighborhood. It's like those super smart beings agreed that we needed to have the freedom to shape our own future and destiny, following our own path of development without external contamination. The idea is that these super advanced civilizations could be like, 500 million years ahead of us, which would explain why we haven't seen any signs of them. And maybe it's better this way, as humans could eventually be destroyed or even assimilated by this new cosmic power, Independence Day style. As much as things like going to an art museum might be interesting to us, extraterrestrials probably wouldn't be too thrilled watching us stare at the Mona Lisa painting for hours. Interplanetary cultures might be more into buying tickets to quietly observe how we're developing new technologies, such as ultra-modern satellites. According to the zoo theory, they can't reach out to us until we hit a certain level of development. So improving our technology and wisdom could be the only way to show them that we're mature enough and don't need their spaceship parenting anymore. There are a couple of reasons why it's hard to buy into the zoo hypothesis. Extraterrestrials might not visit or reach out because we're not all that advanced. But it is tough to explain why they keep ignoring all our attempts to communicate. Even if the zookeepers try their best not to interfere with animals' lives and behaviors. I bet they couldn't just ignore a bear speaking in loud and clear English about its desire to communicate. So that's pretty much why humans keep trying and trying to provoke some reaction from inhabitants of other planets using radio signals. In 2017, in a valley 8 miles southeast of the Norwegian city of Tromsø, a radar antenna transmitted some specially composed electronic music to potential intergalactic listeners. The target audience was in GJ273, also known as Lyton Star. It's a runty red dwarf located 12 light-years from our solar system. Since radio waves travel at the speed of light, we'll have to wait more than 2 decades before looking for a reply. But the main problem with radio waves is that we're kind of in the dark about where to look, and civilizations might be as far as 17,000 light-years away. Plus, we don't know which radio frequency extraterrestrials use to chat. Now here on Earth, we use the radio spectrum to send signals into the universe, assuming that what works for us might be a common method for other civilizations. But in fact, it could be considered a somewhat old-school technique for other beings. That's why current projects are now looking for technosignatures, which are signs of technological activity from extraterrestrials, like city lights, solar panels, megastructures, or artificial satellites. Another potential clue is to study the atmospheres of planets orbiting nearby stars, as an advanced civilization might be altering its atmosphere with different gases, making it detectable. Despite decades of observations, there is still no definitive evidence that advanced extraterrestrial civilizations are out there. But that doesn't mean they don't exist. Even by expanding search fields, we're talking about odds much slimmer than hitting the jackpot, with a roughly 1 in 3 billion chance of finding an advanced civilization within a given distance from Earth. Maybe space creatures are responding to our communication attempts, but in a way that we can't understand. The universe has been around for more than 13 billion years, while humans showed up just 200,000 years ago. And this is about 0.01% of the universe's age. It's like we're still learning to talk, while other super smart beings might be sending us messages that are all lost in translation. We keep waiting for a giant UFO to land on Earth and for green ETs with huge eyes to come out of it. But we forget that our intergalactic neighbors could be more interesting in building nanotechnologies to watch over us. They could also be trying to communicate using neutrinos, which are subatomic particles with an extremely small mass that could effortlessly pass through our planet without being detected by our current technological devices. Now, the zoo hypothesis has another issue. It is pretty tough to believe that, with all these civilizations supposedly hanging out in the universe, they would all decide not to reach out to humans. For this to happen, there would have to be a great sense of structure, with a higher intelligence working as the head of the universe, giving them direct orders and clear rules to keep us isolated. But we're talking about billions of possibilities for life, right? More civilizations mean that there are more chances of a violation of this no-contact rule. So, most likely, at least one independent planet would be just as desperate to find life in the universe as we are. Some scientists also believe that if such advanced life had substantially colonized Earth and many other planets, we would know it by now. The zoo hypothesis has 2 other variations that are even more frightening. In the laboratory hypothesis, nobody contacts us because humankind is actually being subjected to experiments, and Earth is essentially a giant science lab. Otherworldly creatures could be analyzing human responses to various survival challenges, such as tsunamis or massive earthquakes. In this case, the no-contact agreement between all other space groups would make a bit more sense, since it's in the name of scientific research for the greater good, at least for them. The planetarium hypothesis, proposed in 2001, suggests that we are living in an artificial universe, in some kind of virtual reality designed to give us the illusion that the universe is empty when it's not. But no possible generator could test this hypothesis. Besides the zoo, the laboratory, and the planetarium theories, there is another possible answer to the Fermi paradox. Nobody contacts us because humans are completely alone in the universe. This is known as the rare Earth hypothesis, and it emphasizes how Earth occupies an incredibly unique position. No other planet could bring life to the universe that could be more than just bacteria. We may consider ourselves pretty lucky, as even a small change in any of Earth's orbital parameters, like the distance from the Earth to the Sun or the rate of rotation, could make conditions too extreme for people or life in general. But again, it's hard to think that we are alone in this vast universe. So, we're back to the paradox. Where is everybody? We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, superdense core is called a neutron star. Some of these neutron stars are extra special, We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with a magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds, a bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our Sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them. Uranus has a 22-year-long winter. On a planet like that, if it was habitable, everything would be frozen and covered in ice, white and gray desert all around. People would have to stock up on food and supplies, make extra sturdy buildings and homes, and always wear thick, warm clothes. Finally, transportation would be next to impossible. But thanks to the Sun, each planet in our solar system has unique weather, climate, and seasons. There are several reasons contributing to that. First of all, it's all about how far a planet is from the Sun. If a planet is close, like our neighbor Mercury, it gets a severe sunbath. But if it's far away, like the dwarf planet Pluto, it gets frigid even during summer. Now, think about how fast a planet spins. Planets that take their sweet time to rotate, like Mercury, have super long days and nights. That means one side gets toasty hot when the sun's out and freezing cold when it's dark. Earth is pretty balanced with its moderate spin speed. The atmosphere matters too. A thick atmosphere keeps temperatures from going wild, but if there's almost no atmosphere, things heat up and cool down immensely. The tilt of a planet's axis and the orbit shape are crucial as well. Even on Earth, places near the poles get 6 months of daylight and 6 months of night. And if a planet's path around the Sun is like an oval, it heats up and cools down more than it moves. Now, no two planets are unique. While some have these changes, others don't. Let's start with Mars, our favorite little planet and potentially our future home. It's the fourth wheel in our solar system and has a quirky way of doing seasons. Like Earth, it has 4 of them, although they're roughly twice as long as those on Earth. But this planet has an eccentric egg-shaped orbit. Because of this, its orbital speed varies more. This influences these seasons. Martian winters last about 4 Earth months. They're also much colder than on Earth. Near the poles in winter, temperatures can get down to minus 190 degrees Fahrenheit. One hemisphere grows an ice cap as winter rolls in, snatching about a quarter of the atmosphere as dry ice. Then, in spring, it gives it back. Mars also doesn't have the luxury of massive oceans like Earth to balance out its extreme temperatures. Scientists believe it might have had some of that in its early days, but now all the water is gone. With no water, Mars can hit very low temperatures in winter and hotter summer days. The grand gas giant Saturn has a slightly more tilted axis than Earth. However, despite its elliptical path and tilt, it stays consistently chilly. That's because it's way out there, far from the Sun's warmth. Even though it's summer, Saturn remains distant and doesn't get too cozy. It also has a thick atmosphere. The atmosphere on a planet acts like a temperature regulator. If some part gets too hot or cold, the atmosphere gently distributes this temperature across the planet. So, while one side might catch more sunlight during its equinox, the thick air ensures things stay relatively cool. Up high in Saturn's atmosphere, though, it's a different story. Temperatures can swing from seriously chilly in summer to an almost absurd minus 312 degrees Fahrenheit in winter. Uranus is the next planet, the ice giant. With an elliptical orbit and a serious distance from the Sun, it's stuck in a perpetual deep freeze. Its thick atmosphere also keeps temperatures frosty throughout the year. Uranus has a wild tilt, 3 times bigger than Earth's. It's almost lying on its side, and is probably one of the most intense places in our solar system. During Uranus's summer, one pole gets full sun, while the other end faces the deep chill of darkness. In fact, because of its weird tilt and rotation, Uranus is even colder than its more distant neighbor Neptune. As we mentioned, each season on Uranus lasts around 22 Earth years. That's as close as we get to George Martin's fantasy books. That's because Uranus takes a leisurely 84 years to complete one path around the Sun, so its journey through the year is very slow. The final planet in our solar system is Neptune. It's the most far-away icy giant. It has a tilt almost the same as Earth's and a nearly circular orbit, so it feels like it's supposed to be a bit more balanced. However, this planet maintains a bone-chilling atmosphere with unimaginably low temperatures. That's because Neptune receives only a tiny 0.1% of the sunlight Earth enjoys. On Earth, there's a gradual temperature shift from near to far. On Neptune, because of its circular orbit, there's only one atmosphere taking a spotlight. Unlike its neighbor Uranus, Neptune gets a bit of warmth from its core. But this warmth doesn't help much. The cold is pretty consistent, whether it's winter or summer. But some planets don't bother with traditional seasons. They just imitate them by having different temperature cycles throughout the year. These planets include Mercury, Venus, Mars, and Jupiter. Mercury is the closest planet to the Sun. Mercury is very weird because one full day-night cycle on that planet equals 176 Earth days. After half a year on Earth, it's finally time for Mercury people to go back home from work. That's because it moves in an egg path. This is also the reason why it has some wild temperature changes. Sometimes it's very close to the Sun, sometimes it's not. At the same time, it has no atmosphere and no protection from the Sun. This results in extremely hot days and extremely cold nights. But that means it has plenty of time to go from scorching hot to freezing cold. When it's farthest, that's Mercury's true winter, or at least how we call it. So if it had seasons, there would only be two. The next planet is Venus. It's a planet of relentless heat. Forget about seasons. It's just plain hot there all the time. It's super close to the Sun, and its almost circular orbit and tiny tilt of 3 degrees mean temperatures stay pretty steady throughout the year. Even in the supposed winter or the middle of the night, the temperature doesn't dip below 820 degrees Fahrenheit. It also decided to have a weird spin. Venus spins in the same direction as it moves around the Sun. That means the Sun is always right overhead, pouring its entire fiery love on the planet's surface. Venus doesn't really do the seasons like Earth. The closest they have to seasons is 225 days with at least 4 hours of sunlight. This you could call Venus's version of spring and fall. Jupiter, the big guy in our solar system, doesn't bother with the whole seasons drama. It keeps things simple with a tiny tilt of 3 degrees, almost as laid back as Mercury. Plus, its orbit is a close match to a perfect circle, so it doesn't have much variation in sunlight. Also, with a speedy rotation of less than 10 Earth hours, there's no time for the appearance of seasons from long nights. Winter on Jupiter is basically a repeat of any other time of the year. And finally, Pluto, which is still not a planet, but still worth looking at. Pluto resides on the outskirts of our solar system. This little outcast is the definition of cold. The temperatures are around minus 380 degrees Fahrenheit. It has the weirdest orbit, too. Its orbit is very long, elliptical, and tilted. Pluto travels a huge distance from the Sun. That, together with an almost non-existent atmosphere, keeps Pluto in a perpetual cold state. Winters there can get a bit more extreme than average. However, the biggest shift someone stranded on Pluto would notice isn't the temperature, but the Sun's brightness. Always thousands of times fainter than our earthly view.